The basic idea behind the distributive property is we want to organize the boxes in the multiplication grid so that they are easy to count. Instead of drawing individual boxes, we will simply write the appropriate number inside the rectangle. For example, we can represent the picture of 5 times 3 by labeling the side lengths of the grid and writing the number 15 inside. The organizational trick that we will use is to break down numbers according to their place values. This is known as the expanded form of a number. For example, the number 534 can be written as 500 plus 30 plus 4. Example, compute 26 times 7. We will start by thinking about the picture. Most people are unable to instantly figure out the total number of boxes inside this grid. However, if we break the number 26 into 20 plus 6, we reduce the difficult problem into two much simpler ones. We can see that there will be 140 boxes in the grid on the left and 42 boxes in the grid on the right. Therefore, there must be a total of 140 plus 42 boxes, which is 182 boxes. This picture represents how the distributive property works. All we are doing is reorganizing the information to make the grids easier to work with. We still need to compute this process symbolically. As always, we start by writing the original problem. What was the first step? It was to break the number 26 into expanded form. Notice the use of parentheses to keep the 20 and the 6 together. The parentheses are known as grouping symbols, and they are used to help with organization. We will see more about parentheses in a later chapter. Then we broke the picture into two separate grids, and the total number of boxes is the sum of the boxes in each grid. We can show this by writing out the two products separately and adding the results together. Then we computed each product, and then we added the results together. And this is the final result, 182. Notice that the equal signs are lined up just as they were in the previous chapter. The presentation here is important. You will be expected to write out each of these steps for all the problems in this section. Example, compute 7 times 23. In this problem, instead of breaking the grid using a vertical line, we'll use a horizontal line, but the underlying principle is still the same. 7 times 23 is 7 times 20 plus 3. Using the distributive property, this becomes 7 times 20 plus 7 times 3. 7 times 20 is 140, and 7 times 3 is 21. 140 plus 21 is 161. Example, compute 246 times 8. It should not be hard to generalize this idea to three-digit numbers. Instead of breaking the grid into two parts, we will break it into three parts, 200 plus 40 plus 6. 246 times 8 is equal to 200 plus 40 plus 6 times 8. Then we calculate the number of boxes in each grid, 200 times 8, plus 40 times 8, plus 6 times 8. 200 times 8 is 1600, 40 times 8 is 320, and 6 times 8 is 48. 1600 plus 320 is 1920. 1920 plus 48 is 1968. So the total number of boxes in that grid is 1968.